Hi, I'm Antoine Weill-Duflos from McGill University. Today, I'm going to introduce the work Evidence of Sensory Adaptation to Kinesthetic Sensation in the Human Somatosensory System. This work was done with my co-authors from Sorbonne University. First, sensory or neural adaptation is defined as a gradual decrease over time in the responsiveness of the sensory system to a constant stimulus. For instance, when you enter a dark room, you have to wait in order to adjust to the darkness. And if then you turn a light on, you'll have to adapt again to the brightness. We wanted to investigate the case of force feedback. Is there a sensory adaptation occurring when we feel forces? In other words, if I'm holding two bags, do I have a constant stimulus of the force, or do I remember what it felt like? Do we have an absolute sense of the force, or is it relative to changes? We designed an experiment to verify our hypothesis. In this experiment, our apparatus was a single motor directly coupled to a round handle. The participant would grab the handle as pictured. The device would produce a torque, which would translate into a force at the fingertip. So for simplicity, I'll continue to say force. They were given the instruction to press the space key on the keyboard when they felt the amplitude of the force decrease. Our stimulus was divided in three parts. The first part was constituted of a rise in amplitude to get to the set point force. The set point force was kept the same within participant and within trials. Then the force was kept constant for 4 seconds. The last part was an exponential decrease in amplitude. Between each trial, we changed the value of tau, the time constant of the exponential function, following an accelerated stochastic approximation algorithm. The value of tau, pictured here, can be viewed as an approximation of the sensory adaptation time. We recruited 58 participants aged between 18 and 73 years old. All the participant trials ended up converging to a value of tau identified as their adaptation time constant. The distributions of the value is pictured here. The mean of the value gathered is 14 seconds. More details are given in the paper, including a second study with a different value of the set point force. We found evidence of sensory adaptation and have a distribution model for it. These results can be applied to the design of haptic interface as a washout filter and solve issues of overheating motors or energy consumption. Thank you for listening.